it's been like a week since I've seen some of you, or longer. I mean, if you think about it, some of you came to class on the Thursday, and you haven't been back because you couldn't get this. You couldn't get to campus. So it's been a long time. I mean, it's been 12 days since some of you, and we're still going to go forward with the exam. So what I'm going to do is I'm going to provide you with all the ammunition you need to. And I know this is a little late. I probably should have got this done on Friday, but what I'm going to do is I'm going to go through those in-class problems here on this video, and then we will look at homework problems and some of the big ideas on a review for the test on Tuesday. I want you to bring to class some homework problems when we, in fact, I'm done, and then we should be good. So I'm going to get my mug off here, and let's go ahead. And what I'm going to do is I'm going to call up the problem. Okay, so here's problem one. In lacrosse, a ball is thrown from a net at the end of a stick by rotating the stick in the forearm above the elbow. Okay, so basically, and omega, the radial speed, the angular speed is 28 radians per second. That's how many degrees, that's how many radians per second it's turning, all right? And the radius is 1.15 meters. Now, some of you that are new to physics or new to things are going, wait a minute, that's a d, that's a distance, or that's a diameter. Well, no, it's the distance from the stick to the where the ball is located. So we'll draw the picture, and they want us to know if the angular velocity of the ball above the elbow is 28 radians per second, and the ball is 1.15 meters from the elbow joint, what is the velocity of the ball? Okay. In other words, this is a great test type question. Could be on the test, or not this particular one, but the same type of thing. And so let's take a look at it. So here's what we have. So this is question, so these are in class, chapter 6, question 1. All right, so basically what we're talking about is here's my lacrosse net here with the ball in it. Here's the stick, and whoosh, we're releasing the ball at this point, and then the stick is going to go ahead and go on through this circular motion. And it came through a circular motion like this to get up here. All right, and this is 1.15 meters. It's rotating. It probably started down here and is rotating at an angular speed of 28 radians per second. That's the angular speed. Now we want what is known as the tangential speed, V. Tangential speed, V. This one's great because V is equal to R times omega. Derivation of that is this is the change in angle. The angle was 0, and now its angle is equal to pi over 2. So it's the change in angle or the change in time that the guy took to get up there. And we just know that that is equal to 28 radians per second. Okay. And oh shoot, we could figure out the time it took him to do that because we know the angle that it went through, so we know the average. So we know the time that it went through. But anyway, this is the average speed. But it's not. This is the final speed. Boom. But we can assume a constant acceleration. I'm sorry, I'm getting way off track. So there it is. Oops, there it is. So it'd just be the tangential speed is 28, is 1.15 meters times 28 radians per second. Remember what I said a long time ago, that the radians is a unitless measure, and so you just pop that in, and you have your answer. .2 meters per second. I think we can squeeze one more problem on here. Hopefully it's not too long. All right, let's go to problem 2. Okay, an automobile with tires that has a radius of 0.26 meters travels 84,000 kilometers before wearing them out. How many times did that tire go around in a circle? Over 84,000 kilometers. That's going to be a huge number. I'd just say it's a lot. The number of times it's going to turn. Okay, well, we can do this. How many revolutions did it go through? How many revolutions? Okay, is equal to, now here's the deal. Here's the deal. It's not as hard as you think. I lost my damn pen. Here it is. Okay, so now here's the thing. The distance traveled is equal to 84,000 kilometers, which is equal to 84 million meters. That's the distance traveled. And the distance is equal to r times theta, the number of angles. In other words, if you have a roller paintbrush, this is the easiest way to do it, to think about it. If I have a roller paintbrush and I'm going to paint this thing, and my paintbrush has a radius r, okay, then it's going to roll along here and paint this distance, okay? So it's going to go through all these revolutions like this and paint that distance, and that's equal to r times theta. Oh, well, they told me what r was. R is equal to 0.26. Then theta is equal to 84 million. This is kind of fun, actually, divided by 0.26. This is not going to be our answer, though. So let me put this in. So I got 8.4. 8.4 second e to the 7th power divided by 0.26. I wind up with 3.23 times 10 to the 8th radians. Well, how many revolutions, how many radians are in one revolution? One revolution is equal to 2 pi radians. Okay? One revolution is equal to 2 pi radians. So, if I want to get the number of revolutions that are in this, I just divide by 2 pi. Okay? So I'm going to divide that by 2 pi. Oh, look, it's going to come out pretty close. Divided by, second. And you got to do this. This is crucial. If I'm going to divide by 2 pi, I got to make sure I put that in parentheses. Bam. Whoops. What did I do wrong? Oh. Now I can do it. 5.1419. 5.1419. 7283 times 10 to the 7 revolutions. I'm going to see if I'm right, because I'm curious about this. N is equal to 5.14197283 times 10 to the 7th power. And there's no units. Yeah, baby. All right. All right, so we're a quarter way done.